Hi and welcome everybody. My name is Robert and today I'm going to talk about clean front-end architecture, tips to success. A little bit about myself. I'm a lead software engineer at adhere. For all of you who don't know the company, it's a provider for IT services in Germany and Austria. So there's the headquarters in Munich and also an office in Vienna where I work. Additionally, I write blog posts. So here is the link for all of you who want to get more information. I started the blog posts, I think, more than 1 year ago, and now I have already 2,900 followers or something like that. So if you like, you can scan the QR code. There is also a blog post about this talk. And if you like it, just like it on medium.com or add a comment or something like that. So when we look at the definition of a clean front-end architecture, one could be this one. It's a set of practices and principles aimed at creating maintainable and scalable and testable front-end code. So there are a lot of buzzwords in there. The main one would be maintainable and scalable, I would say. So in order to get there, there are some principles we have to follow. Here I've listed some of them. So there's the solid principle. I think all of you are familiar with that. Then there is the KISS, the keep it short and simple, don't repeat yourself, and so on. This is all concerning the code base. And then there are also some concerning the architecture. Like the separation of concerns, component-based design, and domain-driven design. So it seems that it is not that hard to build a clean front-end architecture. I mean, we have all the principles, we just have to follow it. But most of the time, I would say, I've heard these sentences. So it says, we've started with clean code and clean architecture, however, now we have something that cannot be as easily maintained as before. Means at first there is clean code, there is no problem with maintaining the code base, but over time it isn't that maintainable anymore. So for that reason, I would like to give you some tips. So let's have a look at an example architecture that's just one example. Here we see that there are several components or several slices. So at first we see the API slice with services and data transfer objects. Then in the middle we have a store with actions and queries. And down there we have the domains or modules with smart and dumb components. So it seems pretty simple, but even with that architecture, some things can go wrong. So if we have a look at the API slice, components may directly communicate with the service layer. Maybe there are stateful services that's and the store is not used, or think of like open API. So we have an API first approach. There's one YAML file which defines all the endpoints and the data transfer objects. And some developer wants to alter something. And instead of doing that in the one file, he does it directly. So this would be one violation. Or another one would be here, it says, actually we don't want to use the data transfer objects. and instead we want to use the front-end models. So we have a mapper here, and that's also a violation, or it could happen that someone just uses the data transfer object instead of the front-end modules. Or here we see there's a differentiation between smart components and dumb components. This can also be violated. Or even the domains could be too heavy. I mean, the logic inside the domains could be too heavy, or the components itself. So it seems that there are, even with this architecture, there are some implicit rules if you see the architecture, but developers may use it wrong. So the first tip would be to define some technical and domain rules. Just write it down, document it somewhere so that every developer knows how to use the architecture. One architecture I'm using quite a lot is the one that Manfred Steyer proposes. Here you see that it's sliced into different domains. So on the left side we have the order, then we have the author, and then there's a shared slice. And within those slices there's a layered architecture. Means we have a feature slice with all the smart components. Then there is a UI slice with all the dumb components. Then there is a domain layer with all the models, the store, and so on. And beneath that is the util layer. And as you can see from the arrow, only from top to down can be referenced. And in order to share something between those domains, we use an API. So there may be internal APIs for REST APIs, for example, and also external to share something. But that's not a silver bullet architecture. It just worked for my case. It's crucial to find your own technical and domain rules. And the next thing is that domain-driven design is a thing that also should be applied to front-end architecture. So every developer has to know the domain, and if he knows the domain, then it's easier to slice all the subdomains and build a maintainable architecture. So bounded context is one buzzword, and the other one is ubiquitous language within those domains. So every developer has to know all the terms within those domains. And there are two books, the blue one and the red one. I think all of you know them. Then the next tip, you've seen that there are some implicit rules. I have given you the tip to write down all the technical rules and the domain rules. And now we have to make it explicit so that no one can violate them. So there are module boundaries we can define. The most common way to do that is using an X. So in context of Angular, an X is like an extension to the Angular CLI to build a monorepo. And if you have a look at the left side, the architecture that I'm using, all the feature, UI, domains, and utils would be simple libraries. And there is one app that includes all the libraries. And the trick is to define tags within all these libraries. So we can say, okay, this library, the order feature, for example, it's in the domain order, and of which type it's of type feature. So there should only be smart components in there. And the other one, for example, is shared. It's the domain shared, and there should only be DOM components. And on the right side, you can see you can enforce those module boundaries. You can say, okay, in this case, type feature can reference DOM components and so on. But if you have a look at one beneath, type UI cannot reference the feature slice. And you can instantly see it in IntelliJ, for example, if you violate it. So that's an easy way to automatically enforce the boundaries. And now I would like to talk about the shared domain, because I've shown you this architecture, and there's a shared slice. And I mean, even in domain-driven design, there is the concept of the shared kernel, but I'm not a big fan of that. So my tip would be to either remove some layers within the shared domain, because I see no reason why there should be any smart component in there or any domain, because there shouldn't, in my opinion, there shouldn't be any domain or feature slices that should be shared. Or you could rename it. I mean, a little bit funny, but you can say, okay, you rename it to dumpster, for example, so that developers may not move components that easily over there, or you remove it at all. So in my case, I've just removed it. There is no shared domain, but that doesn't mean that there's nothing inside each domain. So I would say that code duplication is a thing in domain-driven design that's good, and it's the thing that prevents hard couplings between domains. So in my case, I would always choose code duplication over hard couplings between domains. So here you can see an example. So for example, we have a product. A product may be a different thing in different domains. It may have different attributes and so on. So I would not put it in a shared domain and share it with all the domains. I would say that each one of the domains has their own product. And just a little anecdote about that. We have implemented a software for one of our clients, and it all went fine. All were happy. And yeah, pretty excited. Yeah? and the product owner told us, yeah, perfect, everything went fine. So there is another user group that also wants to use it, but they have a slightly different approach, or they have slightly different requirements, but it's almost the same. So we have asked him further, and then we've seen, okay, in the backend it doesn't make sense to share something because there are too many differences, but actually in the front end it was quite the same at first. And in my head, I mean, I've learned that code duplication is something that's bad, and I was really struggling to just copy the code and move it in a different domain, because we have two user groups. So all the two user groups can have different feature requests. So it doesn't mean that if for the one user group it's good, that it's also good for the other one. So I've just copied everything, and I had a really hard time sleeping because of all the code duplication. But in the end, after some months, I've seen that there aren't that much things that are the same, because I always had to change something. And if I would have done it the other way, I would have a lot of ngIfs in there, and it wouldn't be maintainable. But as I've done it that way that I've just copied it, it was easy to maintain and to change it. And yeah, that's FYI, that's also the same with strongly typed models, for example, or inheritance. I could tell you stories about inheritance where people thought they knew the domain, but in the end, the customer wanted something different, and we had to refactor all of it. So it's never a good way to use inheritance. Always use composition. And the next thing about this architecture I would like to talk about is to use separate API slices. So what I'm talking about, here you see an example. So for example, we have different teams. So in this case, 3 teams. I have the one team from offer, that's the first domain. And it's an open host service, so it provides some APIs, for example, REST APIs or some components. And also other teams want to use it. I mean, at first it's a good approach, but you will see that there may be a lot of communication that is needed between those teams, especially if there are more than 2 or 3 teams involved. I mean, in the downstream, in the consumer part. So every time something has to be changed here in the offer, all of them have to communicate with each other. So, and yeah, a lot of time goes by. So in this case, I would always choose different API slices. So in this case, the team 2 has its own API slice, and team 3 also has its own API slice. And FYI, it's not a good idea if there isn't an upstream. So I've also seen it in some companies that there is a downstream, but there's no upstream. So you cannot change anything down here. And then there are some meetings where all the other teams complain about this team. Yeah, not a good idea. The next one would be to define, it's quite simple, to define ESLint rules. So I've shown you that you have to define your own architectural rules and you have to enforce them. And now it's more about the code. You have to make sure that the code looks the same. So something I don't want to have is that person 1 writes something or implements something, and I know exactly that's from him because of the code style. The code style should be the same. There should be rules defined. Yeah, and it makes it more easy to maintain. So what's a good approach? A good approach would be, so if you have a company or if you work in a company, that there's maybe a parent ESLint config that you can easily extend from, so that in the end all the teams within a company use this ESLint rules, and then you can override some of them that you say, okay, this one, for example, on push strategy, this one is an error. And the main thing here is that you also have to integrate it in your CI/CD pipeline. So it doesn't make sense to define ESLint rules and don't do anything with that. I've seen teams that, for another anecdote, I have done some feature requests for another team, for one of our core teams, because they had a really struggle, and I said, okay, I have time, I can implement those features. It's and then I've just done a merge request, and I've seen, okay, they have others linting rules defined, and And they didn't bother. They said, okay, it's fine. I mean, there were lots of errors, and they said, no, it's fine. You can just merge it, and that's not a good approach. So in this case, take it seriously if there are errors or warnings, or I mean, some warnings are not that bad and problem, but yeah. Yeah, and that brings me to the next thing. Take code reviews seriously. So if you have a clean architecture and a clean code base, it's so easy to get in the wrong direction. And the way to prevent that in the end is always during the code reviews. So if there is someone that doesn't follow the rules or waits until someone is on holidays and then he can merge it. I've also seen that. So they said, okay, the one guy that has the explicit rules that he's on holiday, so we can merge everything. Yeah, okay, yeah, perfect. Yeah, but in the end, we have some rules defined. Both on the architecture side and on the code base side, so we have to follow them. It doesn't make sense if you just ignore them. And yeah, what would be some points during some code reviews? You can have a look at the best practices. So are there any errors, lint or errors or something like that? Are there any violations of the architectural rules? And is the code base clean? So can someone just easily maintain the changes? And yeah, the next thing is about dependencies. I have seen lots of developers who just add dependencies and actually don't know what exactly they're doing. So my tip would be to add additional dependencies very wisely. What do I mean with that? So I would start with the last one. I would always check if there is a way to implement it by myself. So if there is an easy way to implement that, for example, it's a one-liner, then I don't want to add some additional dependencies, because it's always a pain in the ass if you want to maintain a code base if you have too much dependencies. So that would be the first thing. Then I would say, okay, if you say, okay, that's not an easy task for me, I want to add an additional dependency, then have a look at the GitHub repo. And don't do any tricks. So I've seen it in several companies that they're just overwriting stuff. For example, that the library still works with newer Angular versions or something like that because it is not maintained anymore or something like that. Yeah. Or they just create their own repo and fix it. I mean, it's also an approach, yeah. So yeah, also check is it updated regularly? Is it maintained regularly? Yeah, in this case, do your homeworks before you add some additional dependencies. Because in the end, I would like to have a clean architecture and a clean code, and I don't want to go through some code and always think, what the fuck? What happened there? And I have done code reviews and security reviews for several projects, and it's always the same. I always ask myself, why did they do that? Why did they use that architecture? It doesn't work. Or why is it not a clean code? Yeah. So here I've just summed it up. So my tips are to define all the implicit rules explicitly. So document your technical and domain rules. Use module boundaries to make it explicit and to make sure that it cannot that easily be violated. Then simplify the shared domain, because we have seen that everything can be moved to the shared domain. I mean, this is a trick. You can go around those technical and domain rules. You can just move everything to the shared domain. So I've seen teams that there are some domains, and the most heavy domain on the logic side is the shared domain. Yeah, it doesn't make sense if it's the shared domain. Therefore, just simplify it and choose the code duplication over hard couplings. So if you're not sure that it is really the same for two domains, then just copy it. It's always a better choice to just copy it, because otherwise it's not that easy to maintain afterwards if some other feature requests come in. And also use different API slices, define some ESLint rules, take code reviews seriously, and yeah, keep in mind that additional dependencies are bad. So that's it. Thanks for listening.